Domain and range of a relation. So let's move on to a really important part of understanding relations. As you know, in the sections we've covered so far, we've been looking at relations, how they essentially pair up or connect elements from two different sets. Now we're going to dive deeper and explore two key properties of those relations, the domain and the range. Think of these as defining the boundaries of what a relation deals with. Essentially, the domain tells us what values are allowed as inputs into the relation, and the range tells us what values are produced as outputs. Understanding these concepts isn't just about memorizing definitions. It's absolutely crucial if you want to fully understand how relations work and be able to apply them to more complex problems later on. We'll be working through several examples to make sure this is crystal clear, so don't worry if it doesn't click immediately. We'll build up your understanding step by step. Defining domain and range. So let's move on to formally defining what we mean by domain and range. As we discussed on the previous slide, a relation connects elements from two sets. Now, let's break down exactly how we identify those connections. First, a relation from set A to set B is essentially a collection of paired values. We represent these pairings as ordered pairs. Think of it like this. We write it as a B, where A is paired with B. We can write this mathematically as a B. This ordered pair tells us that the element A from set A is related to the element B from set B. It's important that it's an ordered pair, meaning the order matters. A B is different from B, A. Now, let's define the domain. The domain of a relation is simply the set of all the first elements, those A values that appear in those ordered pairs. Think of these A values as the inputs to the relation. Whatever you feed into the relation, those are the elements of the domain. Next, we have the range. The range of a relation is the set of all the second elements, the B values in the ordered pairs. These B values represent the outputs you get from the relation. So, whatever the relation spits out, those are the elements of the range. We'll see this in action with some examples on the following slides, but the key thing to remember is, domain is inputs, range is outputs, and both are found by looking at the ordered pairs that make up the relation. Make sure you understand this slide well, as it forms the foundation for everything we'll be doing with domain and range. Simplified explanation. So now that we've formally defined what domain and range are, let's simplify things a bit. This slide aims to give you a really quick way to remember how to find them. The first bullet point says, look at all the first numbers in the ordered pairs, that's the domain. Think of it like this. In each ordered pair, the first number is your input value, the value that's being related to something else. So, collecting all those first numbers gives you the complete set of possible inputs, which, as we learned, is the domain. And then, the second bullet point states, look at all the second numbers in the ordered pairs, that's the range. Here, the second number in each ordered pair is the output, the result of the relation. Gathering all those second numbers gives you all the possible outputs, which, of course, is the range. So, just remember, first numbers give you the domain, second numbers give you the range. This is a great little trick to keep in mind as we move on to working through some examples on the next few slides, where we'll put this into practice. It will help you quickly identify the domain and range without getting bogged down in the formal definitions. Illustrative examples. So we've now covered what domain and range are, the set of all first elements and second elements in a relation, respectively. We've looked at the definitions and a simplified explanation. Now, to really make sure we've got a firm grasp on this, let's move on to some examples. This slide simply states that we're going to work through a few examples. These examples will help us practice identifying the domain and range of different relations. We'll start with a simple relation and gradually build up our understanding. Don't worry if it doesn't click immediately. That's what examples are for. We'll go through each one step by step, and by the end, you should feel much more confident in your ability to determine the domain and range of any relation presented to you. In the following slides, we'll be given sets, like set A and set B, and a relation defined as a set of ordered pairs. We'll then carefully pick out the first elements to find the domain and the second elements to find the range. Remember, we only list each unique element once in both the domain and the range. So, let's jump into the first example and put our knowledge into practice. Example 1. Let's move on to our first example to really solidify what we've discussed about domain and range. Here we have a relation, let's call it R, that connects elements from two sets, A and B. Set A contains the numbers 1, 2, and 3, and set B contains the numbers 4, 5, and 6. The relation R is defined as a set of ordered pairs, 1, 4, 1, 5, 2, 5, and 3, 6. Remember, an ordered pair simply shows a connection between an element from set A and an element from set B. Now let's break down how to find the domain and range, step by step. Step 1. Identify the ordered pairs. This is straightforward. We simply list out all the connections that are defined in the relation R, which we've already done. 1, 4, 1, 5, 2, 5, and 3, 6. Step 2. Determine the domain. Remember, the domain is the set of all the first elements in these ordered pairs. So, if we look at all the first numbers, we have 1, 1, 2, and 3. But, and this is important, when we write the domain as a set, we only include unique elements. That means we don't repeat any numbers. So, the domain of relation R is the set containing 1, 2, and 3. We write this as 1, 2, 3. Step 3. Determine the range. The range is the set of all the second elements in the ordered pairs. Looking at our ordered pairs, the second numbers are 4, 5, 5, and 6. Again, we only list each unique element once. Therefore, the range of relation R is the set containing 4, 5, and 6. We write this as 4, 5, 6. So, in this example, we've successfully identified both the domain and the range of the relation R. This is a fundamental skill, and we'll practice it with a few more examples to make sure you're comfortable with the process. In the next example, we'll see how this applies when the sets contain letters instead of numbers. Example 2. Let's move on to our second example. As you recall from the previous slides, we're working with relations and finding their domain and range. Here, we're given two sets. Set A, which contains the elements of B, C, and D, and set B, which contains the elements X, Y, and Z. We have a relation called S, and it's defined as a set of ordered pairs. Let me list those ordered pairs out for you. We have X, BX, CY, and DZ. That's our relation S. Now let's find the domain. Remember, the domain is the set of all the first elements in these ordered pairs. So, if we just list out all the first elements, we have a B, C, and D, and importantly, we only include each element once. Therefore, the domain of relation S is the set containing a B, C, and D, which we write as a B, C, D. Next, let's determine the range. The range is the set of all the second elements in the ordered pairs. Looking at our ordered pairs, the second elements are X, X, Y, and Z again. We only list each unique element once. So, the range of relation S is the set containing X, Y, and Z, which we write as X, Y, Z. See how straightforward it is? We simply identify the first and second elements of the ordered pairs, remove any duplicates, and express them as sets. This will be very useful as we move forward and encounter more complex relations. We'll continue to practice this with another example on the next slide, so you can solidify your understanding. Example 3. Let's move on to our third example. As you know from the previous slides, we're practicing finding the domain and range of a relation. This time, we have a relation called T. Now let's look at how this relation is defined. We're told that T is a relation from a set C to itself. That means both the input and output values come from the same set. Set C consists of the numbers 2, 4, 6, and 8. We can write that as C equals the set containing 2, 4, 6, and 8 with curly braces around it. The relation T itself is defined as a set of ordered pairs. Let's read them out. 2, 2, 2, 4, 4, 6, 6, 6, and 8, 8. Remember, each ordered pair tells us how one element in set C is related to another. Step 1. Identify the ordered pairs. We've already done that. They are 2, 2, 2, 4, 4, 6, 6, 6, and 8, 8. Step 2, determine the domain. Remember, the domain is all the first numbers in each of those ordered pairs. So if we just list them out, we have 2, 2, 4, 6, and 8. But, and this is important, we only list unique elements. That means we don't repeat any numbers. So the domain of relation T is the set containing 2, 4, 6, and 8. We write that as 2, 4, 6, 8. Step 3, determine the range. Now for the range, we look at all the second numbers in the ordered pairs. Those are 2, 4, 6, 6, and 8. Again, we only list each number once. So the range of relation T is the set containing 2, 4, 6, and 8, which we write as 2, 4, 6, 8. Notice something interesting here. In this particular example, the domain and the range are exactly the same. That doesn't always happen, but it's good to observe when it does. We'll continue to practice with different examples, and then we'll move on to discuss some common mistakes students make when working with domain and range, as you'll see on the next slide. Key takeaways. First, remember that the domain of a relation is simply the set of all input values. Think of it like this. If you were to feed numbers into the relation, the domain is the collection of all the possible numbers you could feed in. Next, the range of a relation is the set of all output values. These are the results you get out of the relation after processing those inputs. So, if the domain is what goes in, the range is what comes out. Now, this is a really important point. When you're figuring out the domain and range, you need to list each unique element only once. We saw this in our examples. Even if a number appears multiple times as the first or second element in our ordered pairs, we only include it once in the domain or range set. It's like making a list of names. You don't write the same name twice, right? Finally, and this connects back to how we defined relations initially, the domain and range are actually subsets of the original sets we started with, sets A and B. Remember, set A was the set of all possible first elements, and set B was the set of all possible second elements. The domain will always be a part of set A, and the range will always be a part of set B. It might not include all the elements of A or B, but everything in the domain and range must also be found within those original sets. Let's recap what we've learned about domain and range with these key takeaways. All right, with these key takeaways in mind, we'll move on to look at some common mistakes students make when working with domain and range. Understanding these pitfalls will help you avoid them in your own work. Common mistakes. Let's start with the first point, forgetting to list unique elements only. Now, remember in our examples, like with relation R, S, and T, we pulled out all the first numbers to find the domain and all the second numbers to find the range. A common mistake is to write down every instance of a number as it appears in the ordered pairs. For example, if you see the number 1 appearing twice as the first element, you might mistakenly write it down twice in the domain. But remember, when we define a set, we only list each element once. So, the domain should contain only the distinct or unique values. Next, we have confusing domain and range. This is super common. It's easy to get the two mixed up. The key is to remember what each one represents. The domain is all the inputs, the A values, the first numbers in each ordered pair. The range is all the outputs, the B values, the second numbers in each ordered pair. So always double check. Are you listing the first elements for the domain and the second elements for the range? A little trick is to say to yourself, domain is for the X values, range is for the Y values. It can help keep things straight. Finally, let's look at including elements not present in the relation. This is a subtle one. Sometimes you'll be given sets A and B, and then a relation defined within those sets. It's tempting to include all the elements from sets A and B when listing the domain and range. But that's incorrect. You only consider the elements that actually appear in the ordered pairs that make up the relation. For instance, if the number 5 is in set B, but it doesn't show up as the second element in any of the ordered pairs of the relation, then it doesn't belong in the range. So now we're moving on to a really important slide, common mistakes students make when working with domain and range. This is where we solidify our understanding by anticipating where things can go wrong. So, keep these 3 points in mind as you practice. Avoiding these mistakes will ensure you have a solid grasp of domain and range, which is crucial as we move forward with more complex relations and functions.